Okay, welcome to Lesson 4, Part 2, Triangle Inequalities, Pythagorean Theorem, Distance Formula, Converse of the Pythagorean Theorem, Medians, and Inequalities. Now we did the first 4 topics in Part 1. Now we're going to talk about medians and some triangle inequalities. Okay, to start off with, we have a triangle here. This is an introduction to the medians. These blue lines are called the medians. They go from a vertex to the opposite side, and they bisect that side so that the two segments the side is broken up into are congruent. Now the interesting thing about medians in a triangle is no matter what kind of triangle it is, the medians all meet at one point. That one point with the red dot is called the centroid of the triangle. So we have an intersections of medians in a triangle theorem. It says that the medians of a triangle intersect at the centroid, a point that is 2/3 of the distance from each vertex to the midpoint of the opposite side. Now to put those words into a picture, we have this. So we have our 3 medians, and then we're going to specifically look at median AC. Now we know that B is the centroid, and what this theorem says that the distance from A to B, this distance right here, is equal to 2/3 the distance of the entire median of AC. So if we want to figure out AB, we have to multiply AC times 2/3. And we can use this formula to manipulate and work around to try to find other lengths in the triangle. So here we have 2 examples using medians. And using the knowledge that we just learned, I'd like for you to try these examples with your group by pausing the video. Go ahead and do that now. Okay, example 1. We see that AC is a median and it's intersecting BD. And we know that the distance BC equals 5. Well, we know that medians bisect their opposite side. So that means if BC is 5, then CD must also equal 5. Next we have all 3 medians in number 2, and we see that B is the centroid. And we know that if AB equals 18, we want to know what does BC equal. Well, there's not a formula to figure that out. But what we can do is we can solve and see what is the entire AC equal, and then subtract AC minus AB. We know that the formula will be AB equals 2/3 of AC. If we substitute in 18 for AB, we can now solve. So we multiply by 3/2, and we find out that AC equals 21. Well, if AC equals, it doesn't equal 21, it equals 27. So we know that it equals 27. Well, if we do 27 minus 18, that gives us 9. So 9 is what BC equals. Next we have the first of our 3 triangle inequality theorems. The first triangle inequality theorem states that if you know all the sides of a triangle, that the longest side is opposite the biggest angle, and the smallest side is opposite the smallest angle, meaning the middle side is opposite the middle angle. So if you just know the sides of a triangle, you can figure out which angle's the largest, which angle's the smallest, and which one's in between. So if we're going to list these angles from largest to smallest, we're going to look here, and we have our measures of 8, 7, and 6. So it looks like 8's the biggest, and it's opposite A, so it's going to go angle A, then angle B, then angle C. The next triangle inequality theorem is the opposite of the first theorem, basically. This says if we know all the angles, we can say that the largest angle is opposite the biggest side, and the smallest angle is opposite the smallest side. So we can tell the size of our sides if we know the measure of their angles. So if we're going to list the sides from smallest to largest, we're going to look at our angle measures, and it looks like there's 40, 60, and 80. Well, angle A is the smallest, and it's opposite of BC, so it looks like it's going to go BC is the smallest, then AC, then AB. So that's triangle inequality theorem 2. The third triangle inequality theorem actually tells us, can we make a triangle? Is what's pictured really a triangle, or is the picture fooling us? It says that if triangle ABC is a triangle, then this has to be satisfied. If you can add side A plus side B, it has to be greater than side C. Side B plus C has to be bigger than A plus C has to be bigger than B. So basically what we're doing is we're looking at all the sides, we're adding up 2 of them, and it has to be bigger than that third side. If it's not bigger than that third side, then it is not a triangle, and the picture's fooling us. So let's try to do some examples with these theorems. These first 2, I want you to list what's being asked, so I want you to pause the video with your group and figure this out. Now, please. Okay, starting on the left, we're going to list the angles from largest to smallest, and it looks like the order goes angle B, angle A, angle C, and on the right we're listing the sides from smallest to largest, and this looks like it's going to be AC, AB, and BC. These last 4 examples I want you to try with your group are using that third triangle inequality theorem. Can these pictures right here, can they be actual triangles? Or is the picture wrong? So use that third triangle inequality theorem to figure that out. So go ahead and pause the video and try that now. Okay, start on the top left. 5 plus 8 is 13, which is bigger than 7. 8 plus 7, bigger than 5. 7 plus 5, bigger than 8. So yes, it is a triangle. Top right, 10 plus 12, bigger than 2. 12 plus 2, bigger than 10. But 10 plus 2 equals 12. Equal isn't greater, so no, this is not a triangle. The bottom left, 3 plus 6 is bigger than 4. 6 plus 4 is bigger than 3. And 3 plus 4 is bigger than 6. So yes, this is a triangle. The bottom right, 8 plus 9 is not bigger than 18. 8 plus 9 is 17. So it breaks right away. So no, this one is not a triangle. And there is lesson 4, part 2.